Alright, here's another video. This one I'm going to configure IPSec VPN using crypto IPSec profile. So here's the network diagram here. There's already an existing GRE tunnel between R2 and R4. Let's take a look at that. Okay, so there is tunnel 0 on R2 and tunnel 0 on R4, and I have OSPF running between R1 and R2, and then also OSPF running between R4 and R5. And then for OSPF in R2, I am including the gig 0/1 and the tunnel 0 interface into the OSPF process 1 area 0. And similarly in router 4, gig 0/1 and tunnel 0 is also included in OSPF 1 area 0 for this side of the equation. And so basically I'm routing OSPF for all the loopbacks and the gig 01 in R1, gig 01 in R2, and tunnel 0 in R2. Likewise, I'm routing the loopbacks for R4 and R5, and also gig 0/1 for R4 and gig 0/1 for R5. So I should be able to ping from R1's loopback all the way to R5's loopback. Let's do a test real quick here. Ping 5.5.5.5 source loopback 0, and there it is. I'm able to do that. And so now we are going to do a packet capture here on the link of R4's outside interface connection here to its default gateway, the ISP. So I'm going to look at this. I'm going to basically right click this gig 0/0 R4 connection, and then I'll do a packet capture, and basically here it is. Is reading R3 gig 00. Wait, gig. Let me see. Let me get rid of this again. Let me click on this, right click, and say packet capture. Right click, packet capture. Alright, R3 gig 00. What it's doing is basically is saying here source is 23.2 from here to the destination of 34.4, which is here. So I'm going to capture traffic that I'm pinging from R1 to R5's loopback. So let's do that. And I'm going to repeat this for 100 counts. And let's go ahead and say start the capture. Go back to R1 and hit enter, and it's pinging. And so now here I am in the packet capture. The packet capture stopped, and so here are all of my packets that I captured. And let's take a look at one of them. So you can see that all the protocols are ICMP here. So basically this is pinging over a GRE tunnel, so nothing's being encrypted. So let's take a look at one of these guys, and you can see here that the source and destination is going to be the outside interface of R2 and R4. That's a given. But if you look at the IPv4, you can see that the source is 1.1.1 and destination is 5.5.5. So that's in the clear text there. It's not hiding that. It's not encrypting that. So in this demo tutorial here, I'm going to configure IPSec VPN between R2 and R4 so that the pings, when we do a package capture, it will not show the 1.1.1 pinging 5.5.5 because that inside traffic should be encrypted. So here is R2, and here are the parameters that I'm going to use configuring my crypto parameters. I have my crypto IPSec policy kind of defined already here. I have my authentication protocol algorithm defined and my encryption algorithm defined for phase 1, which is to bring the tunnel up, and then phase 2, which is to encrypt the data. I have that already defined of what I want to configure it as. So this is basically my template. I'm going to hop into router 2 right now and configure my crypto maps. So here I am in router 2. So let's go ahead and configure this. Config T first of all. Crypto IPSec policy. Let's give it a number of 10. And then from here, I want to see what my options are. I want to make sure that I have an a hash algorithm, which is my authentication algorithm, and then my encryption algorithm for phase 1. So I'm going to use encryption, and here is what I want to use. Encryption, I said I want to use AES 256, but what are my options? My option is triple DES and AES. I believe AES is a stronger encryption option here, so I'll use AES 256 on that, and then that's it. And then I want to configure hash, which is SHA 256, and that's that. And then what are my options here? Group, for group, I want to use a Diffie-Hellman group of 14 is typical, commonly nowadays, group 14, and lifetime is going to be about 24 hours, just to make sure we keep the tunnel up. So that'll be 30, what is 86,400? 86,400. So that's 24 hours in seconds. All right, so let's see what we have so far. Also, I need to say authentication, pre-share key is how we're going to authenticate. Pre-share, enter, show run. And there it is. That's my IPSec policy 10 for router 2's phase 1. So I'm going to copy this, and then I'm going to do the same thing here for router 4, which is the other side. So now I'm over here on router 4. I'm going to paste that in. Okay, that's great. Now I want to configure the pre-shared key. Crypto. IPSec. Crypto, what are my choices here? IPSec key. See, this is what I want here. This is my pre-share key that I'm going to use, key. And here I give it a name. I'll call it what I defined earlier, which is my pre-share key. My pre-share key. All right. And oops, the address that I'm going to share this with is the other side, which is R4's outside interface, which happens to be 64.124.34.4. 64.124.34.4. All right, done. Show run. And I'm going to copy the same thing for R4, but I am going to change the IP, of course. So let's go to R4, and this is going to be sharing this key with R2 outside interface, which is 64.124.23.2. Done. All right, so phase 1 is completed. Let's look at R2 here. Make sure we have our login console is happening so we can see real time. All right, and then same thing with these guys over here, and same thing with these guys on R5. All right, and now let's see if what we have for ISACamp. Show crypto ISACamp. Let's see. Okay, so nothing's connected yet. R4, we have to do the phase 1 of R4. Did we do that already? Show run. Okay, so R4, we've just finished configuring crypto ISACamp policy 10. All those other parameters are there. So now we have to go for phase 2, which is the crypto IPSec configuration. So go back to R2 real quick. Crypto IPSec. And here, I want to create a transform set. My transform set is the name that I'm going to use. And then here I need to provide the authentication algorithm and also the encryption algorithm. The authentication algorithm, here's my choice, is going to be MD5 or SHA-256, etc. I'm going to choose SHA-256. All right, and then if I hit the question mark, now it's asking me to finish up with the encryption algorithm. And here I want to use AES for the encryption algorithm. And AES, you have to add a 256-bit key. Okay, so that's done. That's my transform set. And mode is basically going to be tunnel by default, but I'm going to type it in anyways. And let's see here. So I have my transform set configured here, and now I'm going to create a profile because I'm not using a crypto map access list style configuration. This is going to be the crypto IPsec profile style. So here we go, config T, and I want to say crypto IPsec profile, crypto IPsec, spell it wrong, my IPsec profile, enter. All right, and then here what I want to do is I want to set my transform set to this profile, which I configured earlier. It is called my transform set. Done. And then also here I can also set the PFS, perfect forest secrecy, and typically we use group 14 nowadays for that. So we'll set that there, and I think that's it. Show run. right, so that's good there. I'm going to copy this over to R4 because it's pretty much doing the same thing. All right, so that's done. All right, let's see here. Okay, I'm on R4 and I want to verify IPSec's complete for phase 1 is configured. Crypto IPSec transform set parameters are there for phase 2, and that looks good. Now I need to apply these crypto parameters to my tunnel interface. So because right now we don't have anything going on here, so let's add this to the tunnel interface. Tunnel 0, tunnel protection is what I want to use. Enable tunnel protection, IPSec profile, and it's called my IPSec profile. Anything else there? That's it. Boom, done. Same thing on R4. There it is. Now the neighbor is formed in tunnel 0 on R2 to R4. Show IP OSPF NEI. We can verify that tunnel has been formed to R2. And so now I believe the IPSec tunnel is up. Show crypto IP ISACamp SA. There we go. QM idle and active is what we want. There's your destination. Here's the source, and the other way around. And same thing for R4. Show crypto ISACamp SA. All right. Same on R4. We're gonna do a show crypto IPSec SA. And here we can see some packets are being encrypted and decrypted already. So that's good. And it's active here. We have our transform set defined. So what I'm going to do now is ping across from R1 to R5, and let's see here. Right now we have about 19 and 20 packets encrypted and decrypted. Let's clear the counters. Clear crypto IPSec SA counters. IPSec SA. Counters. All right, let's take a look at that again. Okay, 0. So now I'm going to ping another 100 across to R5, and I should see about 100 packets being encrypted, decrypted, and there it is. All right, so that's good. Now I want to do a packet capture while I'm pinging it from R1 to R5's loopback, and I'm going to capture that here. I'm going to do a new capture here on this same link. Right click on that and hit packet capture. And remember before we were seeing the source and destination of the loopback addresses, But since now we are doing a VPN, IPSec VPN encryption, I should not be able to see 1.1.1 pinging to 5.5.5.5. So let's go ahead and do let me just clear this, and let me just do a start capture, go back to R1 and do the same ping. All right, it's pinging, and packet capture stop because it exceeded 50 captures. And so now let's go to page 5, and let's just click on this guy right here, and you can see that the internet protocol is what I'm looking at here. And first of all, let's go back here. How do I get back here? Let's do another ping really quick. Let me clear this guy. Clear, and then start the capture again, and let's just do it again. I want to show you guys something here. All right, well, what I wanted to show was that now the protocol is ESP, right? Before it was ICMP, now it's ESP. So that's good, right? And so now I'm going to choose one of these packets and just take a look here. Let's choose 17, and here it is. Clearly the outside interface IP is showing from 4 to 2 and from 2 to 4, but you don't see the 1.1.1 and the 5.5.5 because that is being encrypted. Let's see if I can look back at another one. What's interesting is, how do I go back to all of the, let's clear that again. Let's do another capture. Waiting for packets. All right, it stopped. Source is from R2, destination R4, and clearly we don't see the 1.1.1 pinging to 5.5.5 earlier. So there you have it. Basically, that is showing that traffic is being encrypted. Of course, the outside IP address is going to need to show because while the packet traverses through the internet, it needs to know the source and the destination of the outside interface, outside IP. So there you have it. That's how I configure the IPSec VPN between two endpoints. And now, so the important thing to look is for active and QM idle on your ISACamp, and then for your crypto map, when you do when you do the crypto IPsec essay, what you want to do is say include caps, and that'll verify that packets are being encrypted and decrypted. So let's go ahead and remove these configurations. And to do that, we have to first remove it from the tunnel interface. And let's do that here. And then also need to remove the transform set. And then that's pretty much it, I believe. And then also the pre-share key. All right, and so that is the way to do that. I'm going to remove that onto R4 as well. See how when I remove it, I got all these errors now. OSPF is down. IPSec is having issues. And also go back to R2 here. Get rid of this crypto transform set. And policy, pre-shared keys. I'm going to change the address 23.2. All right, and now I am back to the original, and if I do a packet capture here, let me clear this, do a packet capture, go back to R1, do the ping again, go back to the packet capture, and we are back to protocol ICMP. There's no more ESP. And so there you go. That is pretty much proof that IPSec VPN was configured earlier, but now we're just pinging through the GRE tunnel, and your source and your destination is in the clear, and also your source and destination IP address of the outside interface is always going to show. All right, that is it.